So if you click this video, there are high chances that you already know what A9G board is and are here to learn how to use A9G board without AT commands and without any external microcontroller using Micropython firmware. And well, if it's so, you are on the correct video, as in this video, I'll be sharing you some Micropython scripts for A9G board using which you'll be easily able to write and read data onto the A9G board's GPIO pin. You'll be able to send the SMS from A9G board. You'll be able to get the GPS coordinates on it, and not only that, we are also going to write a script about making communication with the cloud MQTT broker to send and receive data via GPRS connectivity using Micropython. So after watching this video, you'll easily be able to make your own IoT projects by just using the A9G board standalone. So let's quickly get started. This video is sponsored by LTM, and they came up with an amazing product called as LTM 365. So LTM 365 is an electronics product design platform that unites PCB design, MCAD, data management and teamwork. So with LTM 365, you can do the PCB designing task, you can share your projects over web for review purposes. It do cover sharing your PCB file to mechanical teams so that they can create the mechanical product package based on your PCB. Then it also provides centralized cloud storage, so you don't need to rely on one single computer for your files. It also helps you with managing your components and get real-time supply chain data for your components. It also allows multiple people to work on single project. And in the end, it also helps you with sending your design to final manufacturing units. So LTM 365 takes care of all other tasks, so you put more time and effort in making something creative and useful. And the good part is you can try out its free version as well. I'll leave its free trial version link down in the description of this video, so do check that out. And now let us start with this video. Okay, so here is the A9G board, and now if you want to buy this board, well, we are selling it at an amazing price through our website, whose purchase link is down in the description of this video. So by default, the A9G board comes with the AT commands firmware built in, and now if you want to change its firmware to Micropython, well, you should watch out my previous video in which I have shown the step-by-step process about changing the A9G firmware to Micropython. Its link is down in the description of this video. So after changing its firmware to Micropython, we are ready to install the Micropython scripts in it, but before that, we need to do the programming connections. Yes, you can't program A9G board directly with the built-in micro USB port. Rather, you will need a TTL converter. So here I'm using the smallest TTL programmer made by team techiesms, which is set to 5 volt logic level. Now, if you want to buy this programmer, well, its purchase link you can easily find in the description of this video. So we made the connection between the programmer and the A9G board according to this connection diagram. So after that, I'll connect the programmer with my computer and I'll press and hold the power button on the A9G board for 2 to 3 seconds to power up this board. Now we are ready to jump onto our computer and install the scripts onto the A9G board. Okay, so here is the Thonny IDE. So the first step which you need to do after connecting this A9G board with your computer is you just need to go to run, click on configure interpreter. Here just select Micropython generic, and here just select the COM port on which your A9G board is connected via programmer. After that, just click on OK and just click on this stop button. And here you should be able to see this Micropython version, whichever version you have installed with A9G module. If this appears, then you are good to go to write your Python scripts, and you can test it out here as well. If I type here as print hello world, and if I press enter, as you can see, the hello world is printed. That means the Micropython is successfully running onto this particular board. Okay, now we are ready to install the script. So first, let's try to install the LED blink example script. Okay, so here is the script for blinking LED on our A9G board. So let me explain you the script. So first of all, we have imported 2 packages. Now packages are nothing but the libraries that we used to install or include in our Arduino sketches. Similarly, here in Micropython, we used to include the packages. So first is the machine package, which is responsible for interacting with the GPIO pins of the board, and second is the time package, which is responsible for providing the delay inside the script. After that, we have declared one variable LED, which is nothing but the pin 27 acting as an output. Now here 27 GPIO pin is that pin on which the built-in LED of A9G board is connected with, and we will be toggling the built-in LED. That's why here we have declared as pin 27. After that, by default value of the variable value is set to 1, and straight after that we have defined while 1, which is nothing but the infinite loop. So this is same as we used to write void loop inside the Arduino IDE. So inside the while 1, what we are doing is we are setting the value of LED pin as value, which is nothing but 1. So we are turning on the LED. After that, we are providing the delay of 1 second using the time.sleep function. After that, we are toggling the value. Okay, so this time the value will become 0, and after that it will again jump onto this line and it will turn off the LEDs. So this is how we are toggling the LED at an interval of 1 second. Okay, now to test this script, what you need to do is you need to click on File, click on Save As, select Micropython device here, and here you need to save the script with the name called as main.py. Now why main.py? Well, as soon as this Micropython device boots up, it will run main.py script by default. So if you save it with this name, and if you power up A9G board separately, it will by default run main.py script automatically. That's why you should save with the main.py name. Okay, I'll click on OK. And it installed that script inside the A9G board. I'll turn on the secondary camera to show you whether this script works or not. Okay, so here is the A9G board. As of now, as you can see, no LED is not at all blinking on this board. Well, to test that out, you can just click on the play button. Okay, and as you can see, the LED on board started blinking at the interval of 1 second. Okay, and this will work if you power off A9G board separately as well. So this was first script to write data to GPIO pin. Now let us write a script to read the data from GPIO pin and do some task. Okay, so what I'll do is I'll write a script for turning on this LED based upon the status of the push button connected with the A9G board. Okay, so here is the script for turning on and off the LED using button. So what changes we made here is we declared one more variable called as button, which is nothing but the GPIO 26 pin acting as the input. So we'll be attaching a push button at GPIO 26 pin. And what we are doing next is we are reading the button status by typing the command button.value. And if the button status is 1, we are turning on the LED, else we are turning it off. A very simple script, but this will help you to control the things with the help of a push button. Okay, so similarly we are doing the same thing here, which is we'll be saving this file with the name main.py inside the Micropython device. I'll select this, click on OK, it will overwrite it, click on yes, and we have successfully installed the script. I'll again start the secondary camera. Okay, so now I'll click on the play button here. And yeah, as you can see, the LED on the board is turned off. So now if I press the button, as you can see, the LED got turned off, and if I release the button, the LED got turned off. So it is working based upon the status of the button. So we are successfully able to read the data from the GPIO pin and write the data to GPIO pins. And this is how you can interact with your A9G board using Micropython. Now let's just move one step more ahead and let's just try to send SMS using A9G board. Okay, so here is the script for sending the SMS, but before that, what I did is I have inserted the VI SIM card onto my A9G board. Okay, now here one thing you need to make sure that this A9G board supports the SIM card with only 2G connectivity. It won't work with the 3G and 4G network bands. So make sure if you're using any SIM card, let's cross check that your network provider provides the 2G connectivity. Okay, so after inserting the SIM card, let's just move on to understanding the script for sending the SMS. So here we need to import one important package called as cellular. Now the cellular package is responsible for all the cellular activity like sending, receiving SMS and calls and GPRS and everything. Okay, and after that we have declared imported the time package again for providing the delay. Okay, now here what we did is we have defined one user defined function called as SMS handler, which is responsible for receiving the SMS and sending the SMS as well. Unfortunately, this receiving SMS function or the command is not working. That we'll see while running this script. I don't know why and how, but yeah, it is not working, but we are successfully able to send the SMS. Okay, so after defining the custom SMS handler function, you need to provide the name of the function here inside the command cellular.onSMS. After that, by typing cellular.sms, you need to provide the mobile number on which you need to send the SMS with the country code, and after that you need to type the message which you want to send. In my case, I am sending hello from A9G and .send function. Now this line will help you to send the SMS to the dedicated mobile number. Okay, after that it will be inside the while loop forever, as it will be waiting for SMS reception, but we won't be able to do that. And after doing everything, it will just print as done once it comes out from the while loop. Okay, so now I'll save this inside the Micropython device with the same name called as main.py. Click on yes, and yeah, it got successfully saved. And now I'll click on the run script button and let's just wait for the SMS to be received on this mobile. Okay, here it says SMS sent, and here in my phone, as you can see, let me turn on the screen recording on the smartphone. And here inside all messages, as you can see, I got the message called as hello from A9G board. So yeah, we were successful for sending the SMS from the A9G board to the mobile phone. And if I send the message from here, like from the mobile phone to the A9G board, let's see what happens inside this shell. As you can see, it says that module object don't have any attribute called as SMS received, which is this. Okay, so it is unable to find this particular attribute inside the package, you can see, and for that reason we are not able to receive any SMS. Well, I took the script from one GitHub repository by Pulkin, and majority of the Micropython scripts which I use in this video are based upon this repository. So I'll leave the link for this repo as well down in the description of this video, so you can check out other examples as well. Okay, so we were successfully able to send SMS, unfortunately not receive SMS, but anyone of you watching this video may know the solution about how we can receive the SMS. Well, do drop your suggestions and solutions down in the comments of the video. And after learning about the SMS, now let's just take one more step ahead and let's just try the GPRS connectivity over MQTT. Okay, so I'll show you the example code about how to send and receive data over MQTT over GPRS. Okay, so here is the script for Adafruit MQTT. So I've made this script particularly for Adafruit MQTT. So if you are using Adafruit, well, you can follow the script. And if you're using any other MQTT broker, you need to provide the credentials like the username, password, server name, everything here. Okay, let me take you this whole script and let me teach you how the script works. Okay, so first of all, including the important package is pretty common. After that, here is one new command or function you can say, which is cellular.gprs, and here we need to provide the APN name of your network provider to make successful GPRS connectivity. Okay, in my case, I'm using the Vodafone Idea SIM card and its APN name is www. In your case, it may be different, so you need to search for it and you need to provide that APN name here. Okay, after that, I have declared two topics. One is LED topic and second is the sensor topic. Now, those who have used MQTT before must be knowing what a topic actually is. Okay, so here the LED topic is relay 1 and the sensor topic is temperature. Okay, in your case, it will be different for sure, that you need to provide here. After that, what we are doing is we have declared one LED variable, which is nothing but the pin 27 as output. So the built-in LED is declared as an output in this particular line. After that, here we have to provide the time period, like now this is the time period for sending the data to the server. So here I'm sending the data after every 6 seconds. If you want to increase or decrease the number, you can change the number here. After that, here this particular function will try to install the UMQTT package in case your Micropython device doesn't have that package. If it is having, it won't install it, but if it doesn't have, it will just install that by running this command. Pretty convenient, right? So after that, here again we declared a user defined function called as CB, which is nothing but the callback function. So whenever we receive any data from the MQTT server, this particular topic function will be called, and based upon the data received, so if the data received is 0, we are turning off the LED, and if the data received is 1, we are turning on the LEDs. That we are doing here. Okay, now let's just see how we are sending the data. But before that, we need to provide a couple of more credentials like the name of the device, which can be a random name, but it should be unique for all the devices connected to the same broker. After that, we need to provide a server name. In my case, it is io.adafruit.com. Port number, in my case, it is 1883. Username, in my case, is this. And password is nothing but the AIO key of Adafruit MQTT broker, which is this. This kind of credentials you need to provide for an MQTT broker. After that, we are providing all the credentials inside this function, and using this particular line, we are establishing the MQTT connection. Okay. After that, we are providing the callback function as CB, and we are subscribing to the LED topic, which is nothing but the relay 1. And inside the while loop, what we are doing is we are just checking if the message, if there is incoming message from the Adafruit MQTT broker. If it is so, it will simply call the callback function. And if there is no message coming in, what would it do is it will send the send, or it will call the send sensor function, which is defined here, which is nothing but it is sending the data to sensor topic, and the data is fixed as of now, which is 25. But here you can also attach a sensor and send the sensor's data. Well, I tried to attach the DHT11 sensor with the Micropython device or A9G board particularly, but I didn't find a particular package that supports the DHT11 sensor in it. Hence, I was unable to attach that sensor. But again, if you know how to attach that, if you know proper package of the DHT11 for A9G, you can definitely let me know here. So as I was not able to attach the DHT11 sensor, I am just sending the data 25, but let's just change the data to 100. Okay, so I'm sending the data 100 to the sensor topic, which is nothing but the temperature. Okay, and this is sent after interval of every 6 seconds, and this is the simple MQTT script in Micropython for A9G board. Okay, so now what I'll do is I'll just click on the stop button first, and I will save this script inside my Micropython device with the same name called as main.py. I'll overwrite it, and it got successfully written. Now in the browser, I'll open my Adafruit account. So this is my Adafruit MQTT account, and I'll click on the play button here. Now let's just see if we are getting the data or not. So here we should be able to see the data 100. Let's just wait. And as you can see, so earlier this data was 25, but now it's changed to 100. So our A9G board successfully sent the data over GPRS, our MQTT to our MQTT broker. And now let's test this LED button. But before that, I'll turn on the smartphone's camera to show you the live, working of this project. So here is the A9G board, and if I turn on the LED, okay, as you can see, the A9G board, like the onboard LED turned on. If I turn it off, the LED got turned off. So it is working in real time with a very low latency. And in the meantime, we are also able to send the data, which is shown here inside the shell. Okay, so we are able to work over MQTT with GPRS using A9G board standalone via Micropython. How awesome it is, right? With this, you can make a lot of IoT projects for sure. Now let's just do one more thing, which is let's just test out the GPS connectivity. Let's try to get the GPS coordinates on the A9G board, and let's just see the script for it. But before that, we need to move to some window location so that this A9G board can get the proper GPS connectivity. Okay, so right now I'm sitting near to the window location where I have put the A9G board outside the window so that it can get some GPS satellite connectivity. Okay, now let's just jump on to the script and let's just understand how we can get the GPS coordinate using Micropython. So first of all, two packages are included. One is for GPS and another is for providing the time delay inside the script. After that, by just writing this simple single line command, you can turn on the GPS inside A9G. And in the while true, that is the infinite loop, what we are doing is we are just printing the location, like the latitude and longitude data, and after that we are also printing the number of tracked and visible satellites connected or recognized by this A9G board. And we are printing everything at an interval of 1 second. That's a pretty simple script. And now what we'll do is I'll click on the stop button first of all, and I will save this script inside the Micropython device with the same name main.py. I'll overwrite it, and now I'll just click on the run button, and let's see if we are getting the data or not. So here inside the shell, it started printing the latitude and longitude, but as you can see, the number of satellite tracked and visible are 0. That means it is not connected to satellite yet, but still it is printing the latitude and longitude data. How? Well, the great feature provided by this Micropython script is it can print the previously recorded GPS location even if there is no satellite connectivity. So the last location is stored and it is printing the last location only. And once it gets the satellite connectivity, it will give us the real-time location. Okay, so let's just wait for the satellite connectivity. Okay, so now it got connected to the satellites, and now we are getting the real-time latitude and longitude data. So what I'll do is I'll first of all click on the stop button. Okay, I'll copy this data of latitude and longitude, and I'll open my web browser in a new tab. I'll open maps.google.com. And here if I paste this coordinate, and let's just see what we are getting. Okay, so we are getting the location somewhere here, and as you can see, it is pretty close to the studio. So here is my studio, and here is the this is the location which we got from the A9G board, which is pretty close. And once we take this A9G board outside in an open environment where it can get the maximum satellite connectivity, we can get more accurate GPS location. And yeah, this is working standalone without any external microcontroller. So we can now make our own GPS tracker by just using A9G, because it can get the GPS data and it can send that over MQTT. So I'll definitely try to make a GPS tracker the smallest GPS tracker using A9G board only soon on my channel. So make sure to subscribe to the channel if you don't want to miss out that amazing project coming up on our channel. And yeah, that was all about getting started with A9G board using Micropython. I know I haven't covered all the different example codes about Micropython, but still I'll leave the link for that GitHub repository on which they do have a couple of more example codes down in the description of this video, so you can check it out. So what I did here is I just covered the important things like sending the SMS and sending the data or MQTT, getting the GPS coordinates. So I just covered the important stuff so that you get quickly start with your IoT projects using A9G board. Okay, and whatever problem I faced while using it, I already told in this video. So if any one of you watching this video has a solution for all the problems I discussed, well, do reach me out through the comments. That will be a great help for me. And yeah, that was it about this video. Do click the like button if you appreciate our hard work, and if you got to learn something new from this video, well, make sure to hit the like button. Also let me know your suggestions, feedback, anything regarding this video in the comments of the video. And yeah, that being said, I'm just ending this video here and now. Just wait for my next video. Until explore, learn, share with me, techiesms.